Hey there, curious chemists! Ever wondered why certain substances change color when you mix them with different solutions? Today we're diving into the fascinating world of pH indicators and the science behind those mesmerizing color changes. So, what exactly is a pH indicator? Think of it like a chemical chameleon. It's a compound, often a salt of a weak acid or base, that changes color depending on the pH of the environment it's in. This color change happens because the indicator exists in two different forms, the unionized form and the ionized salt form, each having a distinct color. For example, let's talk about phenol red. At a pH of 7.1, it's yellow, but push that pH just a smidge higher to 7.2, and it transforms to a faint pink. It's like magic, but it's really just chemistry. These indicators are super useful in titrations, a technique used to determine the concentration of a particular substance in a solution. When the indicator changes color, it signals that the reaction is complete. Back in the day, chemists used red and blue litmus papers to test for acidity or alkalinity. These were great, but they had a broad pH range and weren't very precise. Nowadays, we have indicators that cover very narrow pH ranges, giving us much more accurate results. Modern laboratories, of course, use pH meters equipped with pH electrodes for precise measurements. But for quick and visual pH estimates, indicators are still incredibly handy. Let's take a look at how some of these indicators are prepared. Methyl orange, 0.1%. Dissolve 1 gram of methyl orange in distilled water and make the volume up to 1 liter. Methyl red, 0.1%. Dissolve 1 gram in 1 liter of 95% alcohol. Phenolphthalein, 1%. Dissolve 5 grams in 500 milliliters of 50% alcohol. Neutralize it with 0.01 m alkali until a faint pink color appears, and then remove the color with 2 drops of 0.01 m HCl. Potassium chromate, 10%. Dissolve 25 grams in about 100 milliliters of distilled water. Neutralize any chloride with 2 drops of silver nitrate solution and filter it. Make the volume up to 250 milliliters. Quick reference time. Here are some common indicators and their color change ranges. Bromocresol purple, 5.2, 6.8, yellow to purple. Bromophenol blue, 3.0, 4.6, yellow to blue. Bromothymol blue, 6.0, 7.6, yellow to blue. Cresol red, 8.0, 9.6, yellow to blue. Litmus, 4.5, 8.3, red to blue. Methyl orange, 3.1, 4.4, red to yellow. Methyl red, 4.2, 6.3, red to yellow. Phenol red, 6.8, 8.7, yellow to red. Next time you see those stunning color shifts in the lab, you'll know the science behind the spectacle. Until then, keep experimenting and stay curious. See you in the next video.